So today is it the 18th already? Yeah. Wow. And we're going to be solving compound inequalities today. All right, solving compound inequalities. And we just need to touch on something from last week before we get to these compound inequalities. And that is this no solutions or all real numbers is a solution. It's the old, always, sometimes, or never true thing that we touched on it last week. We didn't really get into it. There will be some questions on your quiz this week. So some of your first examples here, you're going to be asked in your assignment is the inequality always, sometimes, or never true? Always, sometimes, or never true. And then you're going to be given an inequality. So let's take a look at -2 times 3x plus 1 greater than -6x plus 7. All right, so this is another case where we have to do the distributive property to the left-hand side first. So go ahead and distribute that. We got the -2 times the 3x, that's -6x. And then we got -2 times 1, and that's -2. And that's greater than -6x plus 7. Now, if you were going to solve this inequality, let's look at these x's here. They're both -6x, agreed? So let's get rid of those first. Now, if you want, you can just scratch them out right now, because what you're going to do is you're going to add 6x to each side. And isn't that just going to eliminate both of the 6x's? -6x plus 6x, that's 0. So that's gone. The -2 falls down. Same over here, that's gone. And you're left with a +7. So now watch. Here's where we're at. This says that -2 is greater than 7. Is that true? No. Is it always true? Is it sometimes true, or is it never true? Okay. So this is what we call this is no solution. And never true. There's no value of x that will ever make this equation true. So there's not a solution for it, and it's never true. Does that make sense? If you get to a stage in the problem where you just got two values left, and what is on your paper is not true, that's a no solution. It's never true. Does that make sense? Okay. So let's look at another one. Let's look at this. Let's look at 4 times 2x minus 3. Less than 8 times x plus 1. So we got to do distributive property on both sides. So right here, 4 times 2x is 8x. 4 times -3 is -12, less than. 8 times x is 8x, and 8 times 1 is 8. You see what's going on with the 12x's again? Does it look to you like it did on the last problem? And didn't the x's end up eliminating themselves? So this is just going to go away, and this is, if you have the same thing on both sides, you can just get rid of them. So don't we got -12 is less than 8. Is -12 less than 8? It is, isn't it? So this is going to be always true. It's always going to be true. And here, this is the symbol for infinite. It's a sideways 8. And this would be infinite solutions. It doesn't matter what you put in there for x. This is going to be true. You can pick any number you want. As long as you put the same number in there on both sides, this inequality will always be true. Now, if you work a problem out, let's say we work out, let's take a look at -2 times x plus 9 plus 7 greater than or equal to 3. Distribute, or you can, we're going to distribute and subtract the 7 first. So we get -2x minus 18 greater than or equal to 3 minus 7 is -4. Going to add 18 to each side. Our -2x is greater than or equal to -4 plus 18 is 14. Going to divide both sides by -2. And our x is greater than or equal to 7. Now, if our x is greater than or equal to 7, is this inequality always, sometimes, or never true? This is sometimes, right? And when are those sometimes? When x is greater than or equal to 7, isn't this inequality true? Yes. Do we divide both sides by a negative? Yeah. Oh, I missed that whole thing right there. That's a good call. Divided by -2, right? Go ahead. And then this side should have been a -2, right? This sign should have got flipped. And what should that 7 be? That's right. Good call. So this is less than or equal to -7. It's still sometimes true, isn't it? And those sometimes are when the value of x is less than or equal to -7. You flip the sign anytime that you either divide both sides by a negative, or if you have to multiply both sides by a negative. All right, so look, let's say you had negative x over 4 less than, we're going to go 12. Okay. If we got negative x over 4 is less than 12, we got to multiply both sides here by negative 4 times negative 4. And since we're multiplying both sides of the inequality by negative 4, these negative 4's cancel. And our x is now greater than negative 48. All right. So anytime you multiply or divide both sides. So when is this true? Always, sometimes, or never? Sometimes. And the sometimes is any time that x is greater than negative 48. So negative 47, negative 46, negative 45, anything to the right of negative 48 on the number line. All right, second part of your assignment is going to be solving the compound inequality. So you're going to be asked to solve and graph your solution. Now, here's what these compound inequalities look like. 7 is less than 2x plus 1. And 3x is less than or equal to 18. This is called a compound inequality. It could have the word and in here, or it can have the word or. Either one. When you get a compound inequality that looks like this, you solve both of them. So here's what I mean. You subtract 1 from each side right here. 6 is less than 2x. You divide both sides by 2. And 3 is less than x. There's one of your solutions. 3 is less than x. And you solve the other inequality. Divide both sides by 3. X would be less than or equal to 6. Now, here's how these graphs work. Draw a number line. Put the 3 on it. And then put the 6 on it. Are we open or closed on the 6? I'm sorry, open or closed on the 3? Open on the 3. Open or closed on the 6? Closed on the 6. Now, x is less than or equal to 6, so we would be going this way. This says that 3 is less than x, or if you rewrote this, this is the same as x is greater than 3, isn't it? If you switch the number and the letter, do you see here how the inequality is pointing at the 3? It's got to stay pointing at the 3 if you change the x and the 3, right? To be the same. So x is greater than 3. So look where we're shading. In between these two values. When you're dealing with these and problems, you're typically going to be shading between your two solutions. Okay. So you solve both. You graph both. If it's an and compound inequality, you're going to be shading between your solutions. The other type of problem that you'll have today is going to be a compound inequality with the word or. So let's say you get 7 plus k greater than or equal to 6, or 8 plus k is less than 3. We're going to solve both inequalities and then graph both solutions. So if I start on this left-hand side and subtract 7 from each side, I get k is greater than or equal to -1. I drop down the word or. I solve the inequality on the right, subtract 8 from each side. And my k is less than -5. All right, just bring them back here, please. Put them on this desk. So now we're going to draw a number line, and we're going to graph both solutions. Now pay attention here that you put these values in the correct place on the number line. All right. Isn't the -5 left of the -1 on the number line? So make sure that we do that. Now let's deal with this -1. Are we open or closed? We're closed. And we're greater than or equal to the -1. So we're going out here to the right. Open or closed on the -5? We're open. And we're going to the left, agreed? So these or compound inequalities, do you see how the solutions get graphed away from each other? And the and compound inequalities get graphed in between. All right, so any questions on what we've talked about today? We did compound inequalities and we did the always, sometimes, and nevers. All right, your assignment for today is going to be on that same page as yesterday. We're going to do page 38 again. But today you're doing problems. Let's do 28 through, let's do 29 through 43, and we're going to do odd. And most of your papers are getting neater and neater every time you turn them in, and I appreciate that. And let's continue that, please. We're going to show all the work. Neatly. All right, show all your work very neatly. Name, date, period number in the upper right-hand corner. All that good stuff.